In prime factorization, we find the set of prime numbers that, when multiplied, give us the original integer. The best way to show prime factorization is using a factor tree, which visibly illustrates breaking up a number into its prime factors. So let's take 54. 54 is 2 times 27, and 2 is prime. A prime number is a number that is only divisible by itself and 1. 27 breaks down into 3 and 9. 3 is prime. So finally, 9 breaks down into 3 and 3. So, 54's prime factorization comes out to 2 times 3 times 3 times 3. 3 times 3 times 3 can be expressed as an exponent, which is a little number attached to a number that tells you how many times a number is multiplied by itself. So 3 times 3 times 3 equals 3 to the third power. So 54 equals 2 times 3 to the third power. Okay, now let's look at 225. 225 breaks down into 5 and 45. 5 is prime. 45 breaks into 5 and 9. 5, again, is prime. 9 breaks out into 3 and 3. 3 is prime. So, 225 breaks out into 5 times 5 times 3 times 3. Or 5 to the second power times 3 to the second power. Next, let's work on 100. 100 breaks out into 5 and 20. 5 is prime. 20 breaks out into 5 and 4. As we know, 5 is prime. 4 breaks out into 2 and 2. 2 is prime. So, 100 equals 5 times 5 times 2 times 2, which is equivalent to 5 to the second power times 2 to the second power. Next up, 125. 125 breaks into 5 and 25. 25 breaks into 5 and 5. So, 125 equals 5 times 5 times 5, or 5 to the third power. Finally, let's look at 36. 36 breaks out into 2 and 18. 18 breaks out into 2 and 9. 9 breaks out into 3 and 3. So, 36 equals 3 times 3 times 2 times 2, or 3 to the second power times 2 to the second power. Now, test your skills on 18. Did you get it right? I hope this film makes finding those prime factors a little bit easier.